how do we find the Fourier series expansion of f of x? So for the given function f of x, the Fourier series expansion is given by a naught by 2 plus summation n equals 1 to infinity a n cos nx plus summation n equals 1 to infinity bn sin nx, where a naught is a constant and an and bn are referred to as the Fourier coefficients. So our job is to find the Fourier coefficients a and bn as well as a naught. Now in the first lecture we shall consider the given function f of x, where f of x is even. Now when the given function f of x is even, then the Fourier coefficient bn equals 0. So we have to find a naught as well as an. So let's take a few examples and let us find out an and a naught. And before that we also need to identify whether the given function f of x is even or odd. So let's consider the first example. So we have to find the Fourier series of the function f of x, which is defined as minus x between minus pi to 0 and x between 0 and pi, right? So therefore we have the given function f of x defined between minus pi to plus pi. And also we need to reduce the series 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus so on equals pi square by 8. Now if you observe the given function f of x, it is discontinuous within its minus pi to plus pi. Now when that is the case, we have to consider the first term of f of x is phi of x and the second one is xi of x. So let us consider phi of x equal to minus x. To check if the given function is even or odd, put x equal to minus x in phi of x. So therefore phi of minus x is equal to minus of minus x, which is equal to plus x, and this is equal to xi of x. So if phi of minus x is equal to xi of x, then the given function f of x is even. If phi of minus x is equal to minus xi of x, then the function f of x is odd. Now here the given function is even. So since the function f of x is even, bn equals 0. So we have to find a naught as well as an. So therefore the function f of x will be equal to a naught by 2 plus summation n equals 1 to infinity an cos nx, and this term becomes equal to 0. So what is a naught? A naught is defined by 2 by pi 0 to pi f of x dx. So therefore 2 by pi 0 to pi x dx. So this is 2 by pi x square by 2 within the limit 0 to pi. So we get 2 by pi square by 2 minus 0. So pi gets cancelled to 2, so the answer is pi. So a naught is pi. So we have a naught equal to pi. Next we need to find an. So an equals 0 to pi f of x cos nx dx. So it is 2 by pi 0 to pi f of x cos nx dx. So again consider f of x equal to x. So this is 2 by pi 0 to pi. So you have x cos nx dx. So which is 2 by pi. So here, since you have the first term which is x and the second term which is cos nx, so I have to integrate two terms here. So you have to use the formula where you have the first term x into integral of the second term. Integral of the second term is sin nx by n within the limit 0 to pi minus integral of the second term, which is sin nx by n into differential of the first term x, which is 1 dx. So this is again 0 to pi. So here observe, for x equal to pi, I get pi into sin n pi. So sin n pi is 0 minus x is 0 here. So this entire term becomes equal to 0. So this term becomes equal to 0. So we have 2 by pi, then you have minus of integral sine nx. Integral sine nx is minus cos nx by n within the limit 0 to pi. So you have 2 minus sign here, so it becomes plus. So you get 2 by pi n square cos n pi minus cos 0. So it is 2 by pi n square cos n pi is minus 1 whole power n minus 1. So this is the value of an. So this is an. So we have found out the value of a naught as well as an. So a naught is pi, whereas an equals 2 by pi n square minus 1 whole power n minus 1. So f of x is nothing but equal to a naught by 2. A naught is pi, which is pi by 2, plus summation n equals 1 to infinity an. This is a. So I can write 2 by pi outside the summation. 1 by n square minus 1 whole power n minus 1 cos nx. So we have to deduce this relation. Now how do we do that? Now observe that f of x is minus x between minus pi to 0 and x between 0 to pi, and we have to deduce this relation. So consider this as equation 1. Put x equal to 0. Now if I put x equal to 0, f of x becomes 0, right? Because f of x is x within the limits minus pi to plus pi equals pi by 2 plus 2 by pi summation n equals 1 to infinity 1 by n square minus 1 whole power n minus 1 cos 0. Cos 0 is 1. So now I bring pi by 2 to LHS. So this is minus pi by 2 equals 2 by pi, right? So when n is equal to 1, I get 1 by 1 square. When n is equal to 1, you get minus 1 power 1 is minus 1 minus 1 plus when n is equal to 2, I get 1 by 2 square. Minus 1 square is plus 1 minus 1 plus 1 by 3 square minus 1 minus 1 plus 1 by 4 square 1 minus 1. So you observe that whenever n is odd, I get minus 2, but whenever n is even, I get 0. So the terms get cancelled out. So this becomes 0, this also becomes 0, and so on. And what is common? This is minus 2. So you have minus 2 here, minus 2 here, right? So I can remove minus 2 common. So you have 2 into minus 2 is minus 4 by pi. You get 1 by 1 square plus 1 by 3 square plus 1 by 5 square and so on equal to minus pi by 2. So minus minus gets cancelled, take pi to this side and 4 gets multiplied with 2. So we have pi square by 8 equals 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus so on. So this is what we had to deduce from the given function, from the Fourier series of f of x. So let's take another example. If f of x equals pi minus x the whole square by 4 within the interval 0 to 2 pi. Now here we observe that f of x is continuous within the interval 0 to 2 pi. In such a case, how do we identify whether the given function f of x is even or odd? Now put x equal to 2 pi minus x. So when I put x equal to 2 pi minus x, I get pi minus x is equal to 2 pi, right? So 2 pi minus x the whole square by 4. So wherever x is there, I am putting 2 pi minus x. So what do I get? I get pi minus 2 pi plus x the whole square by 4. So again I get x minus pi the whole square by 4. Now we observe that pi minus x the whole square is equal to x minus pi the whole square. right? So a minus b whole square is equal to b minus a whole square. So these two are equal. So f of x is equal to f of 2 pi minus x. Now for this condition, the given function f of x is even. So since the given function f of x is even, bn equals 0. So again we have f of x equals a naught by 2 plus summation n equals 1 to infinity an cos nx. So what is a naught? A naught is 2 by pi, 0 to pi, f of x dx equals 2 by pi, 0 to pi, and what is f of x? It is x minus pi the whole square by 4. So this is x minus pi the whole square by 4 dx. So 2 2's are, so I get 1 by 2 pi, and this can be expanded 0 to pi, so you have x square minus 2x pi plus pi square dx. So now I integrate, so you have 1 by 2 pi x cube by 3 minus 2x square by 2 into pi plus pi square x within the limits 0 and pi, which is equal to 1 by 2 pi. So put x equal to pi, so wherever x is there you replace x by pi, you get pi cube by 3, 2 gets cancelled, minus pi cube. So this is x square into pi, so x equals pi, so this becomes minus pi cube, and this becomes plus pi square into x is again pi cube, and wherever x is 0, all these three terms become equal to 0, so you get 0 here. So minus pi cube and plus pi cube gets cancelled, so we get 1 by 2 pi into pi cube by 3, so 1 pi gets cancelled, so you get pi square by 6. So a naught is pi square by 6, so let me write it here. So a naught is pi square by 6. So an equals 2 by pi, 0 to pi, f of x cos nx dx. So what is f of x? F of x is nothing but, you have 2 by pi, 0 to pi, x minus pi the whole square by 4 cos nx dx. So 2 2's are, so you get 1 by 2 pi, 0 to pi. So again this becomes the first term, this becomes the second term, right? So you get x minus pi the whole square into cos nx dx, which is 1 by 2 pi. You have the first function into integral of the second function, which is sine nx by n, where x varies between 0 and pi, minus integral of the second function, which is sine nx by n, into differential of the first function, which is 2 into x minus pi dx. So this is 0 to pi. So here again observe, when I put x equal to pi, the first term becomes 0, right? Pi minus pi is 0, or sine n pi is also 0, and when I put x equal to 0, sine 0 is 0, so this term becomes equal to 0. And then what do we get? We have 1 by 2 pi, so I can bring out minus 2 by n common outside, and then we have again integral 0 to pi x minus pi sine nx dx. So 2 and 2 gets cancelled, so we have so here you have minus 1 by n pi, and this is the first expression and this is the second term. So you have the first term into integral of the second term. So integral of the second term is minus cos nx by n, so within the limit 0 to pi, minus integral of the second term, which is minus cos nx by n, into differential of the first term, which is 1 dx. So this is within the limit 0 to pi. So here we have minus 1 by n pi. I have a minus sign here, right? So let me take this minus sign, put a bracket. When x is equal to pi, you get pi minus pi, which is 0. So the first term is 0. Minus, when x is 0, I get minus pi, cos 0 is 1 by n. Right? Next, minus into minus is plus. I have 1 by n. Integral of cos nx. Integral of cos nx is sin nx by n. So n into n is n square within the limits 0 to pi. So again observe here, when x is equal to pi, sin n pi is 0, and when x is 0, again sin 0 is 0. So this term becomes equal to 0. So how many minus signs do you have? Minus into minus is plus, and then again you have minus into minus is plus. So this becomes positive. This whole term becomes positive. You have 1 by n pi into pi by n. So pi gets cancelled, so you get 1 by n square. So therefore an equals 1 by n square. So let us substitute the value of a0 and an in the equation. F of x equals a0 by 2, which is pi square, by 6 into 2, which is 12, plus summation n equals 1 to infinity, an is 1 by n square, cos nx. Now what is f of x? F of x is nothing but x minus pi the whole square by 2. So you have x minus pi the whole square by 4. Now from this expression we can deduce few relations. Case 1. If x is equal to 0. When x is 0, what do we get? We get pi square by 4 equals pi square by 12 plus summation n equals 1 to infinity 1 by n square, because cos 0 is 1. So bring pi square by 12 to LHS. So you get pi square by 4 minus pi square by 12 equals 1 by 1 square plus 1 by 2 square plus 1 by 3 square, and so on. So take the LCM. So you get 3 pi square minus pi square equals 1 by 1 square plus 1 by 2 square, and so on. So 3 pi square minus pi square is 2 pi square. So 2 pi square by 12 equals 1 by 1 square plus 1 by 2 square, and so on. So 2 ones are 2 6 are. So you get pi square by 6 equals 1 by 1 square plus 1 by 2 square plus 1 by 3 square, and so on. So this is one of the relations what we can deduce from this expression. Case 2. When x equals pi. So when x is pi, you have pi minus pi, which is 0, equals pi square by 12 plus summation n equals 1 to infinity 1 by n square. You have cos n pi. Cos n pi is minus 1 whole power n. So you bring this term to LHS, you get minus pi square by 12 equals, where n is 1, I get 1 by 1 square into minus 1 plus 1 by 2 square into plus 1 plus 1 by 3 square into minus 1 plus 1 by 4 square into plus 1, and so on. Now if I multiply the whole expression by minus sign, we get pi square by 12 equal, so the first term becomes positive now, second term becomes negative because the sign changes. So you get 1 by 1 square minus 1 by 2 square plus 1 by 3 square minus 1 by 4 square, and so on. So this is equal to pi square by 12. So these two relations can be deduced from this expression. Case 1 when x was equal to 0, and case 2 when x equals pi. So in this lecture, in the first lecture, we have considered a few examples where the given function f of x was even. So if the given function f of x is even, we need to find a0 and an, whereas bn becomes equal to 0. So in the next video segment, let us consider a few examples where the given function f of x is odd, and let us see what happens. So do not forget to like, share and subscribe, and press the bell icon to get notifications of all the further uploads, and thanks for watching.